Good day, thanks for joining me. This is the Adobe Fikemba theory. And I told you that in this channel, I will teach you physics, chemistry, and biology. So I've taught physics, I've taught chemistry, and I've also taught biology. So now I'm teaching chemistry. And in chemistry, we've been discussing separation technique. And so I will continue from where I stopped in the previous video talking about separation technique. So let's look at the next separation technique, which is distillation. Distillation. Now, what is distillation? Distillation is a kind of separation technique that involves recovering solvent from a solution. So, distillation is used to recover a solvent from a solution. So, number one, you have recovering of a solvent from a solution. Then number two, distillation. Distillation also means purifying a liquid, okay, that contains a non-volatile impurity. So distillation can be used to purify a liquid that contains non-volatile impurity. So it is also used to what? Purify a liquid that contains non-volatile impurity. Okay? So when we say that this is non-volatile, when we say impurity is non-volatile, we simply mean that on exposure, this cannot catch fire. So it's non-volatile. Okay? It does not catch fire. Volatility. Number three, we can also use distillation to separate two mixable liquids with large difference in their boiling points. We can use distillation to separate two mixable liquids. Take note of this point I'm giving you. Two mixable liquids with what? Liquid with large difference. Take note of this large difference in their what? Their boiling what? Points. Okay? Take for example the separation of alcohol and water. The separation of alcohol and water. So when you want to separate water and alcohol, is used to separate water and alcohol. You notice that alcohol, the boiling point of alcohol is 70 degrees Celsius, and that of water is 100 degrees Celsius. Okay, you can see there's a large difference in their boiling points. Both of them are heated in a distillating flask, and therefore they vaporize. But the alcohol definitely will vaporize first, and it will distillate first before the water because of its own boiling points. Do you understand what I'm talking about? They use this method in gin distillers. All this industry that makes gin, they use this separation technique method to carry out this. So with this, you now know what distillation is all about. In our next video, we're going to be looking at another separation technique, and I guess that should be fractional distillation. In the case of fractional distillation, it is also used to separate mixable liquids, okay? But this time, liquids that have a close boiling point, okay? Fractional distillation has to do with separation of mixable liquids, but liquids that have what? Close boiling points. Do you understand what I'm saying? And for effective fractional distillation, the boiling point between this liquid must be greater than 10 degrees Celsius. Okay? This fractional distillation, I'm already analyzing it. Fractional distillation will be very, very useful in the what? Petroleum industry, where constituent of crude oil can be separated. So I've even said it. Number 7, I'll just put it. The next one is what? Fractional distillation. Distillation. Okay? In fractional distillation, it is used to separate liquids with what? Close boiling point. And for effective fractional distillation, the boiling point, okay, the boiling point difference in these liquids must be greater than what? 10 degrees Celsius. Take note of that. 10 degrees Celsius. Is that clear? And this fractional distillation, it is what is used to basically used in the petroleum industry. They use it in petroleum industry. Okay, and it is used to separate the constituent of crude oil. In our next video, we'll be discussing the next separation technique, and that should be separating funnel, number 8. So we're going to be looking at separating. We're going to be looking at number 8, separating what? Funnel. Thank you. I'd like you to subscribe. I'd like you to share to my YouTube channel. Thank you. See you in the next video.